Hello and welcome to the stream. I'm Jared. You can call me Jardo. We are doing Ruby Advent of Code crimes. We are writing some of the worst code that you will ever see in Ruby. Though, to be fair, really depends on your definition of worst. I think it's some of the best code you'll ever see. You just probably shouldn't do anything we're doing in production systems. And we're not really rising to the level of Trick. If anyone's familiar with Trick, Trick is it's like the IOCCC, the International Obfuscated C Code Competition, except for Ruby. And there's a lot of fun stuff. Yesterday, which was day 6, we wrote this solution where the entry points are just calling the methods part 1 and part 2, and the rest of the implementation is defined inside of method missing using just a big case statement, which includes some method calls to methods that cannot be invoked naturally, like the pound symbol, the caret, and the period. It was fun. You get warnings if you do this because you're not supposed to define method missing on object. Bad things could happen, but only some bad things happened, and we worked through them and came up with a solution. So today we are going to be moving on to day 7. I'm just going to get us set up here. Righty. Oh. So let's take a look at the problem. The historians take you to a familiar rope bridge. These links are all references to previous year's puzzles. In the middle of a jungle. The chief isn't on this side of the bridge, though. Maybe he's on the other side. When you go to cross the bridge, you notice a group of engineers trying to repair it. Apparently, it breaks pretty frequently. You won't be able to cross until it's fixed. You ask how long it'll take. The engineers tell you that it only needs final calibrations, but some young elephants were playing nearby and stole all the operators from their calibration equations. They could finish the calibrations if only someone could determine which test values could possibly be produced by placing any combination of operators into their calibration equations. Your puzzle input. For example, and then it gives us some examples. Each line represents a single equation. The test value appears before the colon on each line. It is your job to determine whether the remaining numbers can be combined with operators to produce the test value. Operators are always evaluated left to right, not according to precedence rules. Furthermore, numbers in the equation cannot be rearranged. Glancing into the jungle, you can see elephants holding 2 different types of operators, add and multiply. Only 3 of the above equations can be made true by inserting operators. Okay. The engineers just need the total calibration result, which is the sum of the test values from the equations that could possibly be true. In the above example, the sum of the test values for the 3 equations listed above is 3749. Determine which equations could possibly be true. Excuse me. What is their total calibration result? Oh, sorry. Hey, Roxy, come here. Good girl. Sit. Thank you. Just taking the dog's collar off so that it doesn't jingle. And it is Be Real, so I have to take a picture of this. Nailed it. All right, quiet stream so far today. So our next I guess we look at our puzzle input. It's gonna look like what we expect. Yeah. And we can copy that into there. That's all good. And then we have to think about how we're going to solve this. So my like gut reaction, because we're trying to do terrible things, was to try and think of something we could do with like eval, where we could like turn this into an actual hash and transform the key side of it into different arrangements of Roxy, what are you eating? What a dog. The operators, but then we'd have to like we have to repurpose an operator because we're told that we just use left to right precedence. So how should we do this? So like I'm thinking about various different things. I'm thinking like, oh, we could do we can implement these as like a tree or like a depth first search. To evaluate each one. That's one way to do it. I mean, that's see that's not like a fun answer though. This doesn't really lend well to a lot of the like silly ideas I had though. What do we do? Because like it seems like if we sort of do a depth first search through the possible solution, like the possible arrangements of operators, because like you can think of it as like 11 is at so if in this example 11 or sort of this example 11's at the top of the root of this tree, and then you can either add or multiply 6, and then from those values you can then either add or multiply 16, and then from those values you can then those elements in the tree you can then either add or multiply 20, and that sort of builds you a tree where each node represents adding or multiplying the next number, and then at the leaves of this tree would represent each possible value that you can get, and you would realistically do a depth first search here because you want to give up as soon as you find a valid leaf, right? Yeah, I mean that that would work. It doesn't feel very inspired though, you know? But we can move forward with that and then see if we stumble across a solution we like. I can think of really terrible things to do, but let's just move forward and then we'll see. So we want to parse these. Parsing them is pretty easy because you can do input lines map. I think Marco at some point suggested there was a better way to iterate over this. Oh, he suggested, I think, read lines. Let's play with that. Let's just see if there was a so file.read let's just IRB in here. Read lines gets me something by the look of things. Okay. Can we tell it to strip the new lines? Read lines to take any options. Name, separator, limit, chances an array, keywords to open, chomp. Oh, there we go. So that suggests that I can do chomp true. Okay, so that's a nicer way to do that. So good idea. We won't always need read lines for some kinds of inputs, but that's a nice way to do that, and avoids me sort of mapping through strip or chomp or something like that. All right, and then so we are summing inputs, or actually let's select. What order do I want to do this? Okay, so let's first map these. So each line, I still have to figure out that bug in my editor. Each line needs to be split into the, let's use the words from the puzzle. These are test values and calibration equations. So this is test value, calibration equations equals line split, and we'll split it on semicolon or colon space. And let's just run this. I like to run code a lot, make sure that it's doing what I expect it to. That looks like it's doing what I expect it to. We could even convert this to a hash. I don't really think there's any value in doing that right now, though. Test value to I is that. So that gets us the test value as an integer, and then the calibration. I guess it's not equations. Equation. Wow. How do they talk about it? They could finish the calibrations if they could only determine which test value could possibly be produced by placing any into their calibrate. I mean, they're calling them. So it's a calibration equation. So we'll split that on spaces and map it through to I, and let's just do that and see what we get. Okay, so that's what we get, and that is totally expected. So the one nice thing about doing the depth first search approach would be that we don't have to deal with any operator stuff. Some of the sillier ideas I had meant we had to do some stuff with operators. So we map these through. We then want to select the ones that are valid, and this will be test value calibration equation. And once we've done that, we want to sum them by their first, which would be the test value here, because it's just an array, it's just a pair. So that's pretty easy. We just then need to do the actual search logic. And we can just do that inside of the select. This code is not nearly bad enough compared to previous days, but I don't yet see how to make it really bad yet. All right. Usually I would do this with a recursive method. Which we can do. Just trying to think. I'm just thinking about designing this. I think we should write a class. I don't know what we call it though. Calibration calculator. That's a terrible name. Calibration calculator. New. Pass in our calibration equation. And then go through each. We'll just implement each on it and calculator each, and select a possible results. And if we want to next true. Oh, actually, we can just use any. If this is an this is an actual iterator. An enumerable. So if any possible results is equal to the test value, then we keep this one. And that's nice. So I think, so enumerable, mix in Ruby. So I haven't done this in a hot second here. But I believe if we just implement each, we can just include enumerable. So let's try that. It's so nice when we were doing day 6, because we'd implemented everything inside of method missing. The Ruby language server didn't pick up any of the methods that we'd defined, and as a result, none of the completions worked for any of the stuff we were typing, which was annoying. All right, calibration equation, cool. And then we just need to define each. And possible results to each do results. Oh, this is very annoying. I should really actually figure that out. Block.call results. And so this is calibration equation. I think so this is going to be a, how do we do this? How do we do depth first search through this thing, given just the array? So this one always messes with my brain. This is one of those things you never ever have to do this in actual Ruby applications. So we want some kind of recursive function, recursive method. That part I know. I don't remember I can't think of what the methods are going to need to be, or what the arguments are going to need to be. Our base case is that remaining results is empty. So if remaining results is empty, we're going to need to handle our base case. And what does our base case mean? It means we want to return the current value or no. What are we passing in? We're passing in we have a current value. No, so if there's only one thing left in the list. No, that's not right. I had it right. So if this list is empty, we return current value. That's right. Okay. I feel like I have to remember how to do this every year, just because it's one of those things that I never actually have to write. Like, we don't write recursive depth first searches through things. That's not a thing we do in our e-commerce work. Not on any normal day. So current value if remaining results are empty, and instead so we're calling this with next value and remaining results. Remaining results is not the right word. It's remaining values. Next value and remaining values is equal to remaining values. And so this isn't a real. This is actually going to do the whole thing, isn't it? That's fine. Whatever. That's not a big deal. If it's too slow, we'll then deal with that. So this has got to return. So we have to there's some flattening that's going to happen. Okay. So it'll be possible result oh, so no, it's current value plus next value and or times next value, and then keep going and then flatten that, right? And that means this needs to return an array. Okay. Right, and that this one is oh, interesting. We have to provide an initial value, which means we need to pull out this at the beginning, because we can't know. We can't provide a base case because multiplication and addition need different base cases, because 0 is the no op for addition and 1 is the no op for multiplication. But that's fine. Alrighty, so this just becomes first value or remaining values. I've used the word results somewhere still to mean the wrong thing. New remaining results, I did it here too. That's a really big number. Is it the right number? Hey, it is. All right. Well, that's pretty fast. It's not very terrible. I don't know what we're going to do to make it terrible, but I'm going to think about that. I am going to think about that. Day 7, part 1. And let's take a look at part 2 and then decide how we want to proceed. The engineers seem concerned. The total calibration result you gave them is nowhere close to being within safety tolerances. Just then you spot your mistake. Some well-hidden elephants are holding a third type of operator. The concatenation operator combines the digits from its left and right inputs into a single number. For example, 12 pipe 34 would become 1, 2, 3, 4, 5. All operators are still evaluated left to right. Now, apart from the 3 equations that could be made true using only those things, we now have some more. Okay. All right, I have an idea for what we're going to do, but first we're going to get this working for both options. So one of the things I like to do that we've done in previous days is once we have a correct answer, what we'll do is we'll make sure that we don't, so that just means that if our part 1 changes, then we will be notified to catch errors. You know, it's a poor man's test suite here. So this is going to be the same. We can refactor this later. So we're just going to parameterize this class and say pipe true, pipe false, and that's still, oh, and we should probably print out. Should probably update my my template at some point, but that's fine. So those produce the same result, and that's to be expected because we haven't actually made the new argument do anything. So let's just store it in here. And here that just means we can possibly provide a third option. And let's just double check. So let's look at our Kevin Newton Ruby operators page, or one of our favorite pages on, oh, where is it? Where did it go? Ruby operators, this one. So the thing that is unfortunate is we can't actually override the pipe operator, I think. No, we can't. So the operators we can override are these ones called call name operators. So I was going to try and do something cheeky and allow us to write something to the effect of possible results, current value or next value, new remaining values if at pipe, and then we can also call compact here. Oh, this doesn't look good. I think we have to do this. There we go. But that doesn't work, sadly, because I can't override what pipe does. So we'll do that. I can't override bitwise but we kind of already played with that, and I don't think it really adds a ton. So I'll keep thinking about this. So this should preserve our original result and error out before we get the second result, and that's correct. We do see that the new value, current value, next value. So what I meant here. Correct. Okay, so now pipe doesn't exist, and pipe is pretty easy to write because it takes two numbers, A, B, and it converts them to strings, concatenates them, and then converts them back to a number. And so this now takes significantly longer because we have added so much, added 50% to each individual element of the tree, which compounds, but it does get us the right answer. Now, this is not the craziest code I've ever written here. So I'm trying to think if there's Oops. Something more fun we could do here. But I'm not feeling really inspired, so I might move on to the next day, to day 8. We're not going to come up with the craziest code for every single one, so we can just leave this one here. Hopefully day 8 has something more exciting to offer us. On that note, I'm going to break these recordings up.